We have 3 large, red. Anyways, if we read that, those are all our marbles. If you add up all these, we have a total of 12 marbles. We have blue marbles and green marbles. We have large and small of each color. So the first question is the probability of one marble being either large or green. Now the formulas are on the top of your sheet. They're not on mine. This is an OR. So OR, what we do with OR is we're going to have two things. And what do we do with the two probabilities? We add them. When an OR, we add them. But we might also have to subtract something. Okay, you're going to have to add the two, but maybe subtract depending on if there's a mutually exclusive something or not. Anyways, so large. So if I'm drawing one thing out, how many of these marbles, well there's 12 marbles to grab from, how many of those 12 are large? I see 3 here and 2 here, so that's 5. And then green. So this is large, by the way. How about green? There's still 12 to grab from because it's still the same pool. And are 7 of them green? Now, the next step, this right here is saying large, green, large and green. Are any of them large and green? Do we have to subtract any large and green marbles? Where are they? There's 2 of them. So we don't have to do 2 12s. Because otherwise, weren't the large green ones counted twice here? Don't we have large green here and large green here? So if we don't subtract them, we counted them twice, and that's kind of, ever heard the phrase double dipping? You can't count it twice. So if we simply do the math here, we get 12 12s minus 2 12s. Looks like we have, we get 10 12s, which reduces to 5 6. We have a 5 and 6 chance of getting a large or green marble. Now, would it make sense that you messed up if you didn't subtract that right there? Because wouldn't that be a 100% chance? And if you think about the marbles, do you have a 100% chance of getting a large or green? No, you should understand logically that something has to be taken out. Next, with replacement, we're doing 2 events. Now, a blue, then a small. Now, it doesn't have the word and or, but is this an and or an or? A blue, then a small. Does that mean a blue and a small? Or blue or a small? So it's and. So ands are multiply. Blue, well there's still 12 to grab from. And how many blues are there? I think it's 5. There are 5 blue. And how many small? Oh, wait, if we put it in, after we take it out, if we put it back in, how many are left to choose from? There are 12 to choose from. So we put it back in. And how many are small out of the bucket? 7. See 5 here and 2 there, so it's 7. Again, since we replaced, we leave 12 there. Alright, multiply straight across, you get 35 out of 144. That is your probability of getting a blue and then a small. Okay, without replacing, I want 2 blues. So 2 blues means a blue and a blue. Got it? A blue and then another blue. So what's my probability of the first blue? How many are blue? We said over here is 5. But for the second blue, if we're not replacing it, how many marbles are left? There's only 11 left after we take one out. And if we took a blue out, how many blues are left? 4. This is called a dependent event. One's dependent on the other. This is called independent. Now you just multiply straight across. 20 over 11 times 12 is, I believe, 132? 33? 132? Okay. Now, I could reduce that. Should I have reduced it ahead of time? Would it have been easier to go like this and make this a 1 and this a 3? And make this a 5/33? Wouldn't it be easier to reduce before we multiply straight across? So, anywho. Okay, last one. Without replacement, we have two events. We have large and we have small. So there's 12 here. How many are going to be here to choose from? 11. And large, how many large are there? I see 5. And how many small are left over? Well, we took out large, so that doesn't affect it. So how many smalls are there? 7. Because when we took out this, it didn't affect how many smalls. Do any of these numbers cancel? No. So my answer, multiplied straight across, is 35 over 132.